Hey everyone, so I'm going to go ahead and go over polynomial factoring or factoring polynomials. So some of this might be reviews, and you might only need pieces of it, so do go ahead, skip to what you need, pause as needed as always, but I'm going to go ahead and start with the starting point, which was greatest common factor. So if you have the notes from my class, this is pretty much going to follow the entire set. But again, as always, you can skip to what you need. So we're going to start with greatest common factor. So again, GCF, greatest common factor. So we're going to factor that out. So again, we're always taking a look to see what do all the terms have in common. So we're going to take a look here. We look at our coefficients and we see that they're 12 and 10. And we should know that they have a 2 in common for a common factor. Next, we're going to take a look at the variables. So we have a cubed and a squared, and when it comes to our variables, we always take the lower exponent, which in this case is a 2. And factoring out the lowest, or the GCF, is just divide everything by the GCF, and this is what will be left in the parentheses for us, which will get us 6a plus 5. So again, if I were actually to distribute this out, if we were to undo this, if I turn this distributed, and I would get 12a cubed plus 10a squared. So I want you to go ahead, pause the video, try the other problems, and then come back and see if you got them correct. Okay, so let's take a look at number 2. When we look at 2, I'm going to look at my coefficients to start off with. We have 14 and 7. So I know 7 goes into both of those. And then they both have the variables m and n. So the lowest exponent for m and n is both 2. So we're just going to divide everything by 7m squared and squared. We're going to keep our minus sign. I'm sorry, not there. So we're going to do parentheses. So 14 divided by 7 is 2. By quotient property, we subtract the exponent, so we get m to the 6 and cubed. Keep our minus sign. And I notice here we're dividing by itself, so that just gets us a 1. Over here on number 3, 18 and 28. So 18 would be 1 and 9. That's not going to work. 2 and 1 and 18, 2 and 9. 2 works, and then 3 and 6. So 2 is what they have in common. They both have p's. They both have q's. So the lowest exponent for p is 6. Lowest exponent for q is 3. So 2 divided by 18 divided by 2 is 9. 8 minus 6 is 2. 3 minus 3 cancels each other out. Keep the plus. 28 divided by 2 is 14. P to the 6 will cancel out. 5 minus 3 is 2. Here, same thing. Now we just have to make sure that we find the GCF of all 3. They're all divisible by 4. Is my greatest divider. And the lowest exponent for both of them is going to be xy of 1s. So 16 divided by 4 is 4. X cubed divided by x is going to be x squared. The y's will cancel each other out. Keep our minus. 12 divided by 4 is 3. X squared, y squared divided by xy is xy. 32 divided by 4 is 8. The x's cancel out. Y divided by y, y cubed divided by y is y squared. So those are what we have. So that is just our quick review of factoring out the GCF. One of the special factorings we have is difference of squares, or difference of 2 squares. So this is a squared minus b squared is the same thing as a plus b times a minus b. And at the top, we do have the first 20 perfect squares. Pretty much when we're filling this out, another way we can think of this is this is a squared minus b squared. We can also think of this as the square root of that first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So that's one way where actually how we're getting the values that go in here is we are going to just go ahead and take the square root of both values is how we're filling it out. So when you take a look at number 5, m squared is a perfect square, and I would actually like to point out that all even exponents are perfect squares. Sorry about that, S. It's pretty up high on the board, so those who see me in the classroom know very well how high it is. Perfect squares, because if we take, doesn't matter what variable what exponent I have, so if I do x cubed and I square it by power property, we would do 3 times 2, which is going to get me 6. I could do x to the 4th squared, which would be 4 times 2. So again, anytime we multiply by 2, we're going to get an even number. So based on that when we square a term and we're going to get a positive back. So all even exponents are going to be perfect squares, which becomes more important the further we go in these problems here. So number 5, we could think of this really as m squared minus 5 squared. So this is my A, this is my B. So by following that pattern, which I guess I'm going to write here, A plus B, A minus B is our pattern. So this is going to be m plus 5, m minus 5. Chat. I want you guys to go ahead, try number 6. But I'm going to take a look at 7 and 9, and then I want you guys to go ahead and try the evens. So looking here at number 7, we do have to go ahead and find a GCF. When possible, always pull out a GCF first. So in this case, they have 5, everything's divisible by 5. R squared minus 16s squared. So this is really R squared minus 4s squared times 5. So again, this is my A, this is my B. So my answer would be 5 parentheses R plus 4s times R minus 4s. And I probably should try to make sure that my s's look like s's. More so than anything else for those that aren't able to actually have the audio on. And on number 9, my GCF would be 7mn. We're left with m to the 6th minus 4n squared. So again, as I said earlier, all even exponents are perfect squares. And we actually did x to the 3rd squared, so we already know that this is really saying m cubed squared minus 2n squared. And I really should. The difference with brackets and parentheses is usually more just for us to see where one starts, when one finishes, when we have lots of parentheses going on. So this is going to be 7mn parentheses m cubed plus 2n times m cubed minus 2n. So we're going to go ahead and pause the video and try the evens right here. All right, taking a look here at number 6, we can see everything is a perfect square. So this is really 9 is a perfect square of 3. So this is really 49 is a perfect square of 7. So this is really 3x squared minus 7y squared with the parentheses here. So again, this is my A, this is my B. So 3x minus 7y, or let's keep the pattern, plus 7y, and then 3x minus 7y. On number 8, we need to factor out a GCF of 2, and we're left with 36c to the 4th minus 1. So I can think of this really as 6c squared minus 1 squared. And I know it's going to be, I just divide, all you need to do for your perfect squares is divide the exponents in half, and that tells you the exponent you need. All right, so 2 parentheses 6c squared plus 1 times 6c squared minus 1. Some of you might be wondering, does it matter the order we put our parentheses? No. However, in the case of your work, typically we will write the last one will be the minus version, mainly because this is the chance of us having another difference of squares, as you may have saw in number 10. So in number 10, they have 10w is my GCF, so with 10w to the 4th minus 1. And I want to stress right now that we need to recall, I'm not sorry, that's not 10, that's just going to be w to the 4th minus 1. That 1 is a perfect everything. So I can't stress that enough, that it doesn't matter 1 squared equals 1 to the 3rd equals 1 to the 4th, which equals 1 to the 5th, which equals 1 to whatever number I want. The answer is still 1. So 1 is perfect everything. So especially whenever we have something that's going to end in minus 1, we do want to be paying careful attention, just because 1 is going to be a perfect everything, so I can always keep going as much as needed. So looking here, we pulled out our 10w, which leaves us w to the 4th minus 1. So I can really think of this as w squared squared minus 1 squared. So when we do that, we will get 10w, w, parentheses, w squared plus 1, and w squared minus 1. So when we're looking here, we should notice that this last term, or this last factor, is yet another difference of squares. So this is really going to have 10w times w squared plus 1 times w plus 1, and then w minus 1. So we are going to go ahead and break that one up. This is going to become a second perfect or difference of squares. As always, pause the video as needed. Moving on to sum of cubes. So sum of cubes is a little bit different for us now. So now we have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So this is a pattern. I will say it's on your formula chart. It's usually given almost on every test. It is a given formula, and it's easier to work based on this pattern. And it's a lot easier to, when we look at these problems, in that we need to break it down to saying, okay, what is this? What is a cubed a perfect cube of? And what is b cubed a perfect cube of? Because these will not be the same thing. These will actually be different numbers unless the number is 1. So we're always just going to go ahead and take the cubic root of whatever we have, of whatever is given, is what we need to do. And we'll see what I'm talking about momentarily. The other thing that is given that you probably need to go ahead and write in your notes is you might want to have a list of perfect cubes. So the first 10 perfect cubes, meaning we have 1 cubed, 2 cubed, 3 cubed, and so on, is going to be 1, 8, 4, 5, 6, 7, 8, 9, 10. Sorry, I probably got off track on that. In that these are the first 10 in order of 1 through 10. So we have 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. Those are our first 10 perfect cubes, and that should get you through quite a bit for what we need. But they are listed in order, so when we're looking at these, I do suggest writing these down so you can go back and count which one it is if you don't have them memorized in order. So we're gonna take a look at, we're gonna start off easy. Let's take a look at number 11. So in this case, any exponent that is a multiple of 3 is going to be a perfect cube. So my exponents for perfect cubes are going to just be any like 3, 6, 9, 12, 15, and so on. So if that is your exponent, they're going to be perfect cubes. And when we're looking at this page, I can already tell you that the only one I need to be worried about is going to be number 16. So I'm going to let you guys, we're going to take a look, but we're going to start off easy. So we have x cubed plus 27. So this is truly x cubed plus 27 is really, so if I take the cubic root of 27, I get 3. So this is really 3 cubed. And so what we need to recall is that we have a plus b times a squared minus ab plus b squared is my pattern we are using. So in this case, a is x, b is 3. So we're just going to fill in our pattern. So I have x plus 3. And then we're going to do x squared plus 3. Well, we'll do it by what the actual pattern is. We're going to say x times 3 plus, oh, and this is not a plus, I'm sorry, this is a minus. I always confuse those when we're starting out. Plus 3 squared. So when we simplify this, the x plus 3 is pretty straightforward. X squared stays x squared. Keep our minus sign. X times 3 is going to be minus 3x here. Keep our plus, and 3 squared is going to be a 9. So x plus 3 times x squared minus 3x plus 9. Is what our final answer would be. Looking at number 13. So m cubed is a perfect cube of m. 216 is going to be 1, 8, 27, 64, 125. Yeah, it must be 216 here. It's going to be 6. So plus 6 and cubed. So we're going to go ahead and do this again. This is my A, this is my B. So we're going to do m plus 6n times m squared minus m times 6n plus 6n squared. So when we do this, we're going to get m plus 6. Make sure we have plus 6n times m squared minus 6mn plus 36n squared. So 12 and 14 are going to be like 11 and 13. So next I'm going to take a look here though at 15 because I'm going to finish off the odds, and then I want you to try the evens. We do have a GCF. My GCF here is going to be 4. So I pull out a 4. 500 divided by 4 is 125. A cubed plus 1. When we divide everything by 4. And again, I'm going to point out these are our notes that in class that things should work out nicely, and that we should, when we're factoring these out because we're practicing difference or sum of cubes, you should have perfect cubes to work with. So if we really think of this, this is really 4 times 5a cubed plus 1 cubed. So this is my A, this is my B. We're going to keep the 4. we're going to have 5a plus 1 parentheses, and we're going to do 5a squared. So 5a squared is going to be 25a squared. A times b, so 5a times 1 is 5a, so minus 5a. And then, as always, we already said 1 squared is 1. So that would be my final answer right here. So I want you to go ahead and pause the video, try questions 12 and 12, 14, and 16. Let's go ahead and take a look at 12 and 16. We should have gotten 2w plus 1 times 4w squared minus 2w plus 1. Because your a value would have been 2w, your b value would have been 1. On 14, my a value, let's change that color. My a value will be 7p, and my b value is going to be 4q. So we're just going to plug this into our formula. So 7p plus 4q times 7p squared is going to be 49p squared minus 7 times 4 is 28. And then PQ, remember, actually do alpha order is what we're using. Plus 4 squared, 16, and then Q squared. On 16, we're going to have to factor out a GCF. My GCF is 3CD. With that, we're going to be left with...
This is the end of B lunch.
8c cubed plus 125d cubed. So based on this, my A is going to be 2c and my B is going to be 5d. So A squared would be 4c squared. B squared would be 25d squared. A times B is going to be 10cd. So if you wanted, one of the things you could do is make this chart first and then fill in your formula and just have everything where it needs to go. So 2c plus 5d. Oh, in the front, I forgot. What did I forget? 3cd in the front. All right. And then for our second part, it is a squared, so 4c squared minus 10cd plus 25d squared. As always, pause the video as needed. Let's go ahead. We're going to move on to difference of two cubes now. Very similar. Notice we do have a change. Our change happens right here and right here. Other than that, the formula is exactly the same. So everything that we just did, it's going to pretty much be the same pattern. Now we're just going to have to make sure that we're using the correct formula. So we have x cubed minus 1. So this is really A is x, B is 1, A squared, B squared, AB. That's why it's on the page. On the screen, we have A cubed minus B cubed equals A minus B times A squared plus AB plus B squared. All right, so I'm just going to follow that pattern. So my pattern says do x minus 1 times x squared plus x plus 1. So since they're actually pretty much the same, the only difference we do have is the different patterns. I do want you to go ahead and try these problems on your own, and we will come back and talk about them. So go ahead and pause the video and give them a try. All right, let's go ahead and take a look here at number 18. 64 is a perfect cube of 4. So this is really A is 4, B is W, A squared is 16, B squared is W squared, and AB will be 4W. So my answer is going to be 4 minus W times 16 plus 4W plus W squared. 19. Everything is a perfect cube here. So A is 6K, B is 5. Again, we're not going to worry about those the signs, the patterns taking care of that for me. So if I did 6A squared, it's going to be 6 times 6 is 36, and then K squared. 5 times 5 is 25, and then my AB is 6 times 5 is 30, and we keep the K. So I'm just going to fill in my pattern. We have 6K minus 5, and then 36K squared plus 30K plus 25. Here on 20, A is going to be M, B is going to be 7N. So A squared is M squared. B squared is 49N squared, with AB being 7MN. So our answer is going to be M minus 7N times M squared plus 7MN plus 49N squared. On 21, we now need to have factored our GCF. So my GCF was 4, so I'm left with 1 minus 8h cubed. So my A value is 1, my B value is 2h, because 2 cubed is 8. So A squared equals 1, B squared is 4h squared, AB is 2h. So I'm going to keep my GCF, and then we start off with 1 minus 2h times 1 plus 2h plus 4h squared. It looks so weird, but it's one of those things that just looks weird. All right, we have 2 as my GCF. So 2, and we're left with x cubed minus 27y cubed. So in this case, A is x, A squared is x squared, B is 3y, B squared is 9y squared, AB is 3xy. So we're going to keep our 2, and then we're going to do x minus 3y, parentheses, x squared plus 3xy plus 9y squared. Those are your parentheses. I do think this is probably the better, easier route to go, is to identify A and then come up with that information and then just input it into the formula. That will make things a lot easier because you're just gonna have to place them where you need to. So for the next part, for the rest of the notes, it should have been a review. So we're starting off with trinomials review. Some of you, this may be where you stop. You're like, Miss, I got that. But just as a reminder, when we have ax squared plus bx plus c, we can use our x here as helping us out, where we're going to multiply a and c here, as it says here, and then have our b value. So we just need to come up with two numbers, again, that will multiply to ac, but add up to b. And we can go ahead and factor out by using factor by grouping. We do first two, last two, and so on, which we are going to review. So on 23, and there is a hint here. If your A value is 1, you can just use your sides, and I'll show you what I mean by that. So on 23, I need a number that multiplies to 56, adds up to 15, so I'm going to use 8 and 7. When your A value is 1, you can actually go straight to this format. So you don't actually have to worry about when A is 1, you can actually go straight to that simplified format. This is just to help you to figure out what they're going to be. Your signs in the middle are going to be, this is a positive 8 and a positive 7. And actually it works on all of them. So that's how I want you to go ahead and do 23 through 30. Is pretty much go ahead, just do the X to figure out what the two pieces will be. So I'm going to pause the video. Actually, I will do 24 as well. Oh no, 26. We'll do 26. And then I want you to pause the video and try the rest of the remaining questions. So negative 42, negative 11. So I do need two numbers. If you're in my class, you should have a list of factors of 1 to 100, but 42 is 1 and 42. That's not going to work. 2 and 21, 3 and 14. And I think this is my best bet. Because my next one I think is 6 and 7. So I'm going to use 3 minus 14 is going to get me negative 11. So this is going to become x plus 3, x minus 4. Oh, I'm sorry, not x. R plus 3, R minus 14. Because again, this is going to be a positive 3. So I want you to go ahead and pause the video, try the remaining questions. Do make sure that you factor out any GCFs that you do have. We are actually, I guess we should look at 29 and 30 is the ones we probably need to look at together. But go ahead and try 24 through 28. All right, so on 24, if I did my X, I need negative 30 and I have 7. So I'm going to do 10 and negative 3. So X plus 10, X minus 3. On 25, we have 64, negative 16, minus 8, minus 8. So X minus 8, X minus 8. We would probably write this as X minus 8 squared. Oh, look at that. I didn't even realize. So on 27, actually, we're going to factor out a W. Let's use a different color. So this was really W times W squared plus W minus 20. So my AC is negative 20. My B is 1. I'm going to do 5 minus 4. So W and then W plus 5, W minus 4. On 28, your GCF is 2A. So we have A plus 17, oh, I'm sorry, a squared plus 17a plus 34. Yeah. That's not 17, that's a 19, isn't it? 19. 19a, there we go. Divide everything by 2. All right, so I need two numbers that multiply to 34, add up to 19. I have a feeling it's whatever my dividing by 2 is. 17. 17 and 2. So my answer is going to be 3a parentheses a plus 17, a plus 2. All right, on 29, they look a little bit different just because I realized that we're still going to have a square in here. Still very similar, just a little different. So I still have negative 24 and I have 2. So I'm going to do 6 minus 4. This is going to be n squared plus 6, n squared minus 4. Which I should realize that this is a difference of squares. So n squared plus 6, n squared, I'm sorry, not n squared, n plus 4. So and n minus 4. On 30, you need to factor out an x first. And we're going to get x to the 4th minus 24x squared minus 25. So I do want you to go ahead and try and base that based on how I did 29. I want you to go ahead and try 30. On 30. So we're going to keep our x. Oh, I guess I should do my new x. My bad. Up top, I'm going to have negative 25. Down bottom, I'm going to have negative 24. So I'm going to say 1 minus 25. All right, so x. And we're going to get x squared plus 1. X squared minus 25. Which is going to tell me a difference of 2 squares. So x times x squared plus 1. X plus 5. X minus 5. So there are those. Again, as I said, as always, pause the video as needed. I'm going to head and move on though. So next we have the last 4 in the trinomials. 31, 32, pretty straightforward. 33, 34. Oh, I lied actually. So 31, 32 is actually going to do factor by grouping after we do our x. 33 and 34 is also going to be the same thing. So we're going to take a look at 31 together. So I'm still going to do my x. This time I'm going to have 24 because this is AC and this is B, so negative 10. So I'm going to do 2 and minus 12. So I'm now going to rewrite this out. 3x squared plus 2x minus 12x plus 8. So if you recall when we went over it, we're going to group the first 2 and the last 2 and pull out the GCF of each group. So the GCF of 3x squared and 2x is x. And I'm left with 3x plus 2. Now, when we're doing this, the whole goal is to get the second set of parentheses to be exactly the same. So we're always going to pull out the same sign that we had here. Hold on. I got that wrong. I own it. I got it wrong. So this is still 24. This is negative 10. I need negative 4 and negative 6. Because I need them to multiply to a positive. The other one would have worked only if I had a negative 24. So this is really 3x squared minus 4x minus 6x plus 8. There, that works out better. So we're going to group first two, last two. This changes. My GCF is now just still an x, so we have 3x minus 4. We're going to pull out the sign, so we pull out -6, or negative, and they have 2 in common. So we're going to pull out a -2, which will leave us with 3x minus 4. So again, our parentheses should match. The parentheses is one of the factors, and then the fronts make up our second factor, or the first one, depending on how you want to look at it. So based on that, I want you to go ahead and do 32 through 34. I'm going to go to 33 just because that's where I'm closer to at the board when I'm writing this. So I'm still going to do my x. 5 times 3 is 15. -15 specifically. 14. So I need 1 times -15. No, -1. I want 15 minus 1. I do write mine in that order for a certain reason, and it has more to do for what we do afterwards. So it's just habit. So 3x to the 4th plus 15x minus x minus 5. So I'm going to group first two, last two. I did that in different color. There we go. First two, last two. The GCF here is going to be a 3x, and I'm left with x. Oh, these are squares. My bad. So GCF is x squared. So we are left with x squared plus 5. And over here, we're going to pull out a -1. And we are left with x squared plus 5. I'm sorry, the quartics always throw me off slightly, but it still should work out. So my GCF, the pair is x squared plus 5. On the outside, we have 3x squared minus 1. On 32, we have -40 and -6. So I'm going to say 4 minus 10. So 8x squared plus 4x minus 10x minus 5. First two, last two. 4x, 2x plus 1 minus 5. So that gets me 2x plus 1. So 2x plus 1 and 4x minus 5 would be my answer. 34. We have 24 and -11. Yes. So that means they're gonna be the same. So since this last line is since this is a plus sign, I know they're gonna be the same. So minus minus. I know it's gonna be whatever the sign's here. So we're gonna say 8 and 3. So 12m to the 4th minus 8m to the 4th minus 3m to the 4th plus 2. My GCF here in my first two, last two, my GCF is going to be 4m. What? Oh, this is not a 4, this is a 2. This is not a 4, this is a 2. 4m squared, which leaves us 3m squared minus 2. They have a -1 in common, and that's it. So 3m squared minus 2. So 4m, we're going to do 3m squared minus 2. And then we have 4m squared minus 1, which I should recognize that last one as a difference of squares. This is really 2m plus 1 and 2m minus 1 for my final answer. Right, moving on in our notes. So we did have the GCF, so we kind of already went over this. So I'm not gonna go fill those in. Well, I guess I will actually. Group first two, last two, pull out the GCFs. So we have, for the examples on this, I should have done better. X plus 1. And then we have x squared minus 4, which we just talked about, or we've looked at some point, I believe. X plus 2, x minus 2. So I will say one of the things you always have to be careful of is having one of those difference of squares popping up. Or a difference of cubes, sum of cubes popping up as well. Pretty much these are already set up for you to go ahead and do factor by grouping. So I'm going to take a look at number 38, and then I want you to do the rest on your own. So first two, last two. Our GCF here is going to be 2x to the fourth, which will leave me x minus 9. My GCF is a positive 7, and that leaves us x minus 9. So we have x minus 9 times 2x to the fourth plus 7. And you're done with that. So I want you to go ahead and do the other 5 problems and come back and check your work. All right, taking a look here. So we'll start here. First two, last two. X squared is my GCF, so x minus 1. A positive 9 is my GCF, so x minus 1. X minus 1 times x squared plus 9. I can't do anything with that, so I am done. First two, last two. V squared is my GCF. I'm left with 4v minus 5. Negative 4 is my GCF, so 4v minus 5. So I have 4v minus 5. And then we have v squared minus 4. They really do like doing x squared or x squared, v squared minus 4. They really like that one. The other one they really also like is the minus 1 option. Just so you're aware, they really do like having throwing in v plus 2, v minus 2, which with whatever variable you're using. They really do like that one. I'll give you that. So let's take a look at 39, first two, last two. My GCF is c cubed, so c plus 9. My GCF is negative 1. Remember, we're always taking the sign of that first term in that second set. So c plus 9. So we get c plus 9 times c cubed minus 1, which I'm going to point out as I keep telling you, and everybody keeps forgetting, that 1 to no matter what it is 1, so it is perfect everything. So this is a difference of cubes. So c plus 9 times c minus 1 times c squared plus c plus 1. AB 1, yeah. First two, last two. So k squared, so k plus 5. Pull out the minus 1. K plus 5. So we have k plus 5, and we have k squared minus 1. And as I said, they like either doing minus 4, minus 1. So that you should recognize that that is a difference of squares. K plus 1, k minus 1. And on 40, my GCF, first two, last two. 2g, oh, no, sorry, not 2g, just g to the third is my GCF of that first group. So that we're left with 2g minus 3. 8 So I get 2g minus 3. 2g minus 3 times g cubed plus 8. And this is a sum of cubes. So we keep the 2g minus 3. G cubed is a perfect cube of g plus the cube. 8 is a cube of 2. So that's my a and my b. So g squared minus 2g plus 4. And that is the end of our notes. That goes through our review as well as the new special factoring techniques that we have. If you have questions, let me know. But good luck, and I'll see you in class.